voice later in case you want to listen to this again. All right, here we go. A coin is flipped. So a nickel, dimes, anything like that. What is the chance or probability that it lands on heads? Now, some of you, you've heard this kind of before. Some of you. What is the chance that it lands on heads? Anybody know? 50 what? Did we just say 50? 50%. Okay. I'm going to write this over to the side. You're absolutely right. 50%. That's one way we can say it. Okay. Anybody else know another way we might present it? We can also say, and probably for us in this probability unit, it's going to be 1 out of 2. But 1 out of 2 as a percent is 50%, right? Yes? Okay. Another way that we could also write it, percent decimal. So we got percent, decimal, and what is 50% as a decimal? Do you know? That one's a little harder. You could also say 0.5. So these are all ways that we can show probability. Okay? For us, we are primarily going to focus on this fraction form for this chapter. Did everybody hear that? That's really important. For us, for most of this chapter, we are going to present our probabilities in fraction form. All right? Let's take a look at the second one. A spinner has 5 equal sections labeled A, B, C, another B, and another A. What is the probability of the spinner landing on B if we spin it one time? Anybody want to take an educated guess? Say it again. 25%. Okay. Anybody else? Anybody agree with her? 25%? Yes? No? Ms. Laney, thank you for talking up. I appreciate that. Actually, that is not correct, but I appreciate it's okay. It is okay. At least she spoke up. So let's talk about as a fraction. How many total sections do you have? How many total sections? If I have a spinner with A, B, C, B, and A, how many total sections is that? Come on. A, B, C, B, A. How many sections? It's okay. You can say it. 5. Thank you. Montre, thank you. That 5 is going to go on the bottom. How many of those sections we're looking for? What's the probability of landing on B? How many B's are there? 2. So that is the probability 2/5. That's the correct answer. Now, 2/5 is going to be 40%, which is a little bit harder to calculate. It's not 25. And 2/5, we would write that as 0.4. That would be as a decimal. But again, we're going to focus on this as a fraction. So what is probability? Okay? Probability, and yes, you need to write this down. Probability, and that's what the P stands for, probability of some event happening, meaning the probability of landing on heads or the probability of landing on B is equal to the number of successes divided by the number total. Outcomes. Number of successes out of the number of outcomes. Okay? All right. So, then we have specific notation, meaning a specific way that we write things. Okay? Probability notation below. So, the probability that A is going to happen means, and this is what it means, it is the probability of rolling an A, that should be an A, over your total. Now, that's if you're rolling a die, okay? So the probability of A is probability of rolling an A out of the total number of faces on your die. The next one is called, this is called an intersection. Intersection. And it looks like an upside down U, right? Now, to me, it also looks kind of like a small n, but there's no little side piece on the left, right? When you say the intersection of something, we are actually meaning and. So this is the probability of rolling an A and a B over the total. Okay? And the probability of rolling, I shouldn't say rolling, maybe getting an A and a B over total, but I'm going to leave it as rolling for now. All right? So that upside down U means and. Now, if I say that quickly, I told you I think it kind of looks like a small n. Think of it as A and B. A and B, A and B. So it has to be both of them happening. Okay? The next one is a union. U for union. Okay? And this means or. Come on. Or. So this is the probability of getting an A or a B. Probability of rolling an A or a B over the total. But, there's a but in there. It's a little bit more than that, okay? And I'm going to make this kind of come up here. The probability of A or B means I want the probability of A plus the probability of B, because I want as many of them as I can. It's A or B minus the probability of A and B. And you'll see this when we get to it more in a frequency table. Okay? Let's say, trying to think of a good example. Probability of A or B. I don't have a great example. I keep thinking it's boys and girls, and that's not a good example. Let's say, yeah, no, I'm not even going to worry about that. We'll see it later. And the last one. This is the probability of not. That little squiggly sign is not A. So this is the probability of not A over your total. So we have the probability of A, the probability of A and B. A and B. Say it quickly. A and B. That's an and. And that means it has to be happening kind of at the same time. This is a union. We want A or B. So let's say you're A and you're B. A or B would mean all of us together. It's a pretty large amount. But we want to take away any amounts that are already together. That's a little complicated, but we'll talk about that. And the last one, probability of not A. Okay, so let's see how we can use these. Example, there are 14 jelly beans. Any big jelly bean eaters out there? No? Me neither. 14 jelly beans in a container. You win a prize if you guess which color, I love it when this happens, which color marble. So we switch from jelly beans to marbles. We teachers do this all the time. We're just going to put that this is a jelly bean. Should be a jelly bean. Now, let me tell you that this is theory. Okay? This is theoretical probability. This is what is expected. It's not necessarily what's going to happen. So we have 4 purple jelly beans, we have 7 red, and we have 3 orange. All right? Letter A says, how many outcomes are there? Meaning, how many total jelly beans do I have? 14. Okay? Outcomes means total. So you have 14, which is the sum of 4 plus 7 plus 3. Any questions about that? So according to our probability, where is that number going to go in my fraction form? In the numerator or the denominator? If that's my outcomes, my total, it's always going to go on the bottom, right? So what's the probability of choosing each color? Well, let's see. The probability of choosing a purple, how many purples do I have? 4. So that's my successes. That's 4 out of, how many do I have total to choose from? 14. So that's 4 out of 14. Okay. How about the probability of getting red? How many reds do I have? 7, thank you. Out of how many total? 14. And the probability of getting orange is, what's my top number? How many oranges do I have? 3 out of 14. So does everybody understand how I got those numbers? Number of successful picks, I guess you would say, out of the total. Now, here's something else we need to do. We need to simplify. When it comes to fractions, we often have to simplify. When it comes to probability, we need to simplify. So what do both 4 and 14, what is a factor? What can I divide those by? 2 over 2, which gives me 2/7. Now, if you put 4/14 on the test, you will get credit. But mathematically, it is better to write 2/7. Did everybody hear what I said? This is the yes or no. If you write 4/14, unless it specifically says you must simplify, you'll get credit. But mathematically, it's better to write 2/7. How about 7/14? Is that going to simplify into something smaller? Yes. I can divide both of those by 7/7 and get 1/2. So you can write 7/14, but 1/2 is the better answer. All right? And the last one, 3/14, can that be simplified? No. So that one you just leave as is. Any questions about that? All right, I want you to try the bottom there. It's kind of hard to tell, but it says, what's the probability of getting a 5 on this spinner? The spinner says 5, 3, 5, 3, and 3. What's the probability of getting an 8 on a 6-sided die? Are you guys familiar with dice? On a 6-sided die. What's the probability of getting an A out of these balls in the jar? And what's the probability of getting tails? See if you can do that very quickly. At your seat. This is where you need to write it down. You make a mistake, it's okay. We have these things called erasers. They're like really great. You erase and redo it. All right.
Is it 2 5s on there? Only 2.
Yes. It is a little hard to tell, isn't it? I appreciate that. So try that bottom part. Oh, so sorry. Okay. Here we go. The probability. What is the probability of getting a 5? It is 2 out of how many? Class? 6, 5. How many sections are there total? Here's a 1, a 2, a 3, a 4, a 5. So yes, it should be 5. That's okay. You corrected. That's great. How about for the second one? What's the probability you roll a die? Yes, 1 is called a die. What's the probability you're going to get an 8? Have you ever seen an 8 on a 6-sided die? Just say no. No. Good. So that is 0 out of 6, which is 0. Because we can simplify that. So it is 0. What's the probability of getting an A in that jar of balls? 5 out of what? What is it? 7. Did I hear someone say 6? 6, 7, 6. Oh no, did she just do that? Yes, she did. All right, probability of getting tails. You flip a coin. What's the probability of getting tails? 1 out of 2. Can we simplify any of those here at the bottom? Yes? No? No. So they are already in simplest form. Any questions about these notes we took today so far? Don't worry, we're not done. I know, you want more. Give me more, Miss Thede. All right, let's turn to the top of the page. Certain events. The probability that something is going to happen means that it is certain to happen. Okay? So we say the probability of a certain event is equal to 1. If we absolutely know it's going to happen, it's going to be 1. 100%. Okay? The probability of my teaching today is 1. Okay? So what does that mean? That means a certain event, it is a sure thing. It is going to happen. Let's see. For example, e.g. means for example. Don't ask me why. I think it's Latin. Anybody take Latin in here? Do we offer Latin here? At the high school? Do we offer Latin? No? Huh, surprising. So if you have, for example, if you have a bag of marbles, comma, the probability of selecting a marble is going to be 1. Yeah, because it's a bag of marbles. So if you put your hand in and you pull out something, it's going to be a marble. So, impossible event. The probability of an impossible event. Can you take a guess? What is that probability going to be? If it's impossible. 0. Yes. 0. So this is not possible. Not possible. The probability that pigs fly, you've heard that saying, right? Probability that pigs fly, you're like, I once had a pig and it went on Southwest Airlines. Well, that's not what we're talking about. The probability that pigs fly is 0. That's when people say, well, that's going to happen when pigs fly. That means it is not going to happen. Okay? All right. And this is kind of a review of some things we did. The and probability means your intersection. We write that as the probability of A and B. But here's what I say. Say it quickly. A and B. A and B. Has to happen at the same time. A union. A union is the word or. This is written as the probability of A union B. It means we want A or B. We want everybody that we can, but we don't want anybody that's in an overlap. Okay? Let's see. What would be, I need to come up with a good example. Let's say, no, I'm not going to do it. Wait. Let's do this last one. Not probability. That is the probability of not A. Not A. All right. We will stop there. Listen carefully as you are closing that up.